Hey, let's talk about the median. The median is the exact bifurcating point of a distribution. And we can take a very simple array of numbers that's listed in order and easily discern what the median is. If I look at this array of 5 scores down below, 3, 5, 8, 10, 11, in that case, the median is clearly 8. It's the place where the distribution is divided exactly in half. If you had an array of 6 numbers, such as 1, 1, 4, 5, 7, 8, well, in that case, the median is merely the between point of the two middle numbers, which would be 4.5. 4 plus 5 divided by 2, or you could just say it's the middle of 4 and 5, which of course is just 4.5. So a fairly direct concept. So of course, the first thing that one must do is put the numbers in the correct order. You couldn't have them in a mixed array and then just look for the middle number or the middle two. They must be either in ascending or descending order. And I honestly wish your text would list them vertically in descending order, as is APA style. Now, when we're looking at a simple histogram, as we did in a previous chapter. In fact, let's go way, way back. For instance, right here. Here's letter A from our earliest conversation. Clearly the median here, the bifurcating point, and I'm trying to draw the cursor right there, is clearly 5.0. Half the boxes will appear on the left and half will appear on the right. And when something's normally distributed, it's very easy to look where the median is. Same with C. Clearly 5 is the median, although it's not a very representative number. Now, when you get up to B, it gets more complicated. That's tough to tell. But I could maybe look into it. How many boxes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14, 16. Okay, well, fair enough. So in this case, if there are 16 boxes, is there a place that's evenly bifurcating? And kind of not really. I mean, it's there somewhere, but it's between 6.5 and 7.5. So sometimes the array doesn't do you many favors and doesn't clearly illustrate the mean. It's hard to tell, although it is possible to calculate, as we'll talk about, where the exact median there is. However, over here, it's a slam dunk. It's pretty easy. The thing to keep in mind is you're looking, when we're speaking of the median, at the place that bifurcates it exactly in half. Half the boxes fall on one side and half the boxes fall on the other. I would never give you a complex example like this one. However, I want you to recognize where this median is and why it's 3.75. How many boxes are there? 1, 2, 3, 4, 5, 6, 7, 8. Fair enough. My goal is to have 4 on each side of the median if there are 8 boxes. 1, 2, 3, plus 4 quarters. A whole, W-H-O-L-E, plus a quarter, plus a quarter, plus a quarter, plus a quarter. And sure enough, that adds up to 4. Over here, I've got a whole, plus 3 quarters, plus 3 quarters, plus 3 quarters, plus 3 quarters, and that also adds up to 4. So a fairly, direct notion, and I will always pledge to make the median be somewhere that, it's obvious. This is an overly complex example, but nonetheless, I would like to illustrate that it's the bifurcating point, which sometimes is easy to see by the histogram and sometimes not so easy to see. Here's another one that has a mean of 4, but our bifurcating point clearly here is 2.5. This is a weird array of numbers that has a mean that's kind of pulled down by this 12. It's pulled to the high side. But you can see here the median, 1, 2, 3, 1, 2, 3. I got 6 boxes. Isn't 2.5 the exact place that divides those boxes in half? It sure is. 3 of the 6 boxes appear to the left of 2.5. 3 of those 6 boxes appear to the right. So that's a fairly easy median. And in this case, where you have an outlier of 12 that just sort of came out of nowhere, in that case, we'd certainly like to quote the median because that's the better measure of a central tendency. So we'll come back to context in which we use the median, but for our purposes now, just remember it's that exact bifurcating point. Sometimes it's the exact same thing as the mean, but sometimes it's different, as it is right here with this extreme example with the outlier of 12.